Hello! How's it going? In our WebGPU stuff, we've been making models and we've been doing instance rendering. That's pretty cool. But one thing that I want to do is I want to start making some creative effects. So in this video, I'm going to cover basically frame buffers, rendering to an external frame buffer, and just as a test, applying some simple post-processing. The benefit of setting up a multiple frame buffer, multiple render pass approach is that we can start to be more modular about our rendering, and we can start to think creatively about compositing views together. So for instance, let's say that I have some sort of heads-up display and it's got components within that, like, health, ammo, map, or whatever. I can render those components individually onto the display and then composite the display together with a view of the world. But anyway, I'm getting a little bit ahead of myself. So there's a few items, nice and simple. First thing I'm going to do is I'm going to define, oh my goodness, great start. I'm going to define a post-processing, I'll say pipeline type. Then I'm going to write a post-processing shader and build a post-processing pipeline for my renderer class. Then I'm going to write an external frame buffer class. And then finally, I'm going to abstract the individual render passes out to functions. So I should get it to the point where I've got some function that's like, hey, I'm going to render my world. And the function just does that render pass. And then I say, alrighty, now I'm going to apply my post-processing effects. So I'll have a separate function which applies those. And it makes things a little neater. I thought about abstracting the render passes out into actual classes, but for various reasons, it just seemed a little easier at the moment to do it this way. Cool, so let's get Visual Studio Code up. There we are, that didn't take long. Okay, so what I'm going to do is I'm just going to pop over to my source code, into my model, and then here I've got this definitions file where I've defined all these different pipeline types, and I'm going to also say, hey, I've got a post-processing pipeline. And now this will cause an error in my view. I should probably go through this, so, let's find out if it causes an error in my view. So I'll just sort of load it up, npm start, and it says, hey, we've got an error, and that is occurring in my renderer. So I can open up that file, and it says, hey, we've got these dictionaries, basically these hash tables, but you haven't given me something for the post-processing pipeline. So I need to give it something, even if it's nothing. So those errors should now be gone. Little side note, I have modified this code quite a bit because we're going through the tasks of making pipelines, making bind groups and layouts and all of that. It gets a little repetitive. So I actually created factories or builders, and it's worth taking a little look at how this operates. But basically, I've got this builder object, and then I configure the builder, and then I say, hey, now make me a bind group layout, and it makes that. And then after it makes the bind group layout, it resets all of its states, so then I can reconfigure for the next bind group layout, and it just makes things a lot simpler. If you're interested in that, the source code is here in view, and then we have bind group layout, bind group, pipeline. These all work pretty similarly. So we have this reset, which resets the state of the builder object. And then we have these adding functions, which add in entries. When we build it, it creates the thing and then resets itself. But anyway, it just makes things a lot simpler. But where was I? And it says, hey, here we are. And that is all good. Probably good to be continually running this. Okay, so that's the first item done. We've defined the type. The next thing is going to need to write the post-processing shader. So what I'll do here is I'll go over to my shaders folder and I'll create a new file. I'll call that post, or whatever you want. And I'll go ahead, so I'll be lazy, I'll grab everything. So we've got something to work with, at least. Okay, so what am I going to need? I'm going to need some sort of, I'll use that fragment actually. I'll get rid of all this, don't need it. Okay, so my fragment, going to output position, that's fine, and texture coordinate, that's all good. Now in terms of the resources that I'm getting in, I'm not going to need transform or object data. The screen shader, the post-processing shader, is just going to be responsible for drawing the whole screen. So it's going to be very, very inflexible. The only thing I'm going to change is the fragment shader in here. Everything's going to be pretty fixed. So what we need pretty much, we need some texture to write to, and we need a sampler, and I'm going to call those bindings within group 0. There we have it. Okay, so for the vertex stuff, we're going to take in pretty much vertex index is all we need. So this shader will get some info saying, hey, draw, shader 1, shader 2, just like that. And I'm going to create an array to sample from, and these will be the positions of the corners of the screen. So I guess we'll go top right, bottom right. But I can't imagine that's a lot of fun to listen along to. Anyway, the point is, these are the positions on the screen. So here we've got our output. We're going to output some fragment, and we need to set the position of the fragment. And what I'm going to do is I'm going to make a new variable. Let's call it pos. That'll be and I'll get that pos by I just missed something, right? Up here, this is an instance index. We don't want that. I want a vertex index. And I'll call that vertex index. Cool. Point is, if you've seen my ray tracing stuff, this is basically redoing my screen shader. Okay, so I'll take that position, that 2D position on the screen. I will give it a depth of 0, I guess. And there we are, we've got what we need. Then for the texture coordinate, here I'm going from -1 to 1. So if I take that, I'll go pos plus 1. Well, then we're going from 0 to 0 to 2. So I'll need to halve that to then go from 0 to 1. But so there we've got it. And now what I'm going to do for my fragment shader is I'm going to take in that texture coordinate, sample, and pretty much that's all we need. Okay, so there may be some adjustment, but I'm pretty happy with this for now. So I'll leave that and say, okay, we've written a post-processing shader. Okay. The next thing I'm going to need to do is build a post-processing pipeline. So if I go to my renderer, I can see in my renderer that I have this dictionary set up ready to go. I'll just need to, let me see. Okay, so I've got this material. I'm just looking through my bind group layouts and my things. So the post-processing pipeline is going to need, as its bind group, it's going to need a material and a sampler. And that's actually here in the material group layout, because that's the same bind group layout that all of the 2D materials are using. Anyway, so we can reuse that one. Yeah, I'll be lazy. I'll be lazy and do that. Okay. The other thing we could do, I'll be a little less lazy. So if we had to do this from scratch, it would be a case of adding for the fragment shader a 2D material and then assigning that to the post-processing. But it's a situation where these actually have the same bind group layout and there's nothing unique about that, so we could use one or the other. It's fine. Okay, I'll stop rambling. All right, so pipeline. So I'm just going to copy this stuff here that I use to build the standard pipeline, and I'll go through this. So for the bind group layout, I'm going to add the post bind group layout. We don't need to add this, that's fine. We need to add the source code. So as I've got up here, where are we? I'm just going to go ahead and import post. Just like that. And I can then specify that. I'm probably doing all sorts of like bad web development practices by overriding post, but hey, it's fine. So, all right, vertex, VS main, FS main, that's fine. And then we do not have any vertex buffer attributes or anything, so we don't need to do that. I'll get the color format, depth stencil state. We're not doing that. We're not doing depth testing. Then we can be a little more specific because some of this state gets copied over. So bind group layout down below, that gets reset. Our source code does as well, but the color format, I believe, does not get reset at this point. So that should be fine. And we can double test that by sort of starting it up again and crossing our fingers. It works, we can inspect. And that's fine. Cool, so we've built our post pipeline. Now we're going to need to write the frame buffer class. So I'll just go over, and the frame buffer is going to be pretty similar to the material class, because what is a frame buffer? Really, it's a texture that we write to. So I'm going to go ahead and make a new file, call it frame buffer. And I'm going to take all the material stuff. Okay, fun. So we'll need a bind group because, well, this thing will need to be read from, right? So there's two uses for a frame buffer. One is to write to it. And to write to it, all we really need is to define this thing as a texture and have a texture view that we can access. But then to read back from it, we're going to need a bind group, which is why we've got a bind group here. So we probably don't need a name, but I'm gonna take a canvas so we know how big to make this thing. Yeah, bind group layout we're gonna need. I'm also gonna take in a color format, and that's probably all we need. Okay, we're not doing mip mapping on this thing, so I won't do that. But we can then query the canvas and say, hey, what's your width and your height? Now the point of this loop from one of the previous videos is to look through and work out like how many MIP levels to use. We don't have that. Okay, texture descriptor, width, height, MIP level count is 1. Format is the specified format. And then the usage here, we're not going to be copying to it, but we will be rendering to it and reading from it. And we don't need any of this. This is just loading in the images. Okay, view descriptor. MIP count is 1, but all the rest of this looks okay, except for format we can put in our specific format. Yeah, I'm happy with all of this. We can basically get rid of the anisotropic filtering. We're not worrying about that. Okay, and I'll just go ahead and get rid of this stuff here. Okay, so with our Framebuffer class in place, we can go ahead and actually make that. So we'll go to our renderer, we'll say, hey, import Framebuffer, and then we're going to have down here some sort of some sort of Framebuffer instance. And then here where we create our assets, I'll go right down the bottom. Yeah, so again, it's a bit of a weird thing that we actually have these things, like on paper they're using different layouts, but the layouts are the same, so it should be fine. Cool. Okay, so then we've created and initialized our frame buffer. So as far as this item goes, I'm happy with that. Now we're just going to need to make these separate render pass functions. It's actually not too bad to do that. So what I'll do is I'll minimize all of this. And then I'll go down to this render stuff, and I'll actually copy this over a few times. And there's a bit of a subtle point here. The original render function was asynchronous, but it turns out that the asynchronous part is just in the submission of work. Like submitting, you have your command encoder and it encodes all your draw commands, and that's synchronous. That works, from one step to the next. But then when you go ahead and send that off and submit it to the GPU, that's the asynchronous operation. So it turns out that if we just deal with recording draw commands, that is not asynchronous. It's synchronous. So I'm going to go ahead and call this draw world. And to draw the world, we're going to need all this info, plus we're also going to need a render command encoder. Okay, so we're not going to do this early exit stuff. We'll pretend that was already handled for us. I'll get rid of this. So this will again be created by the calling function. So I'm going to create the render pass thing here. Okay, so for the view, oh my god, why are you doing that? Why are you doing that? Okay, so we'll get the view of our frame buffer. Clear value I think we don't need, because we're just redrawing everything. And we're not going to be doing depth testing, so we won't have a depth stencil attachment. But yeah, this will do the rendering as before, but just onto that object. So we'll do all this draw stuff, and then down here where we end the render pass, that's fine, but it's this queue submission that we want to defer for later. So you can have multiple render passes working on the single object. So we've got that. I'm just going to go down here, just put this render 2 or something, just to deal with this original function. Then I'll go back to my render function and say, okay, first up we'll go ahead, create that command encoder, but then all this stuff will be draw world. So everything right down to where we submit that queue. Okay, so draw world, just like that. Now if we go ahead and run this, there we go. So we're seeing nothing, but that's actually okay, because if we go and inspect, oh my goodness, maybe it's not okay. What are we getting? Someone's laughing right now. My bad, we do need to specify the depth stencil, because of course this is the bit where we do the 3D rendering. It's later on where we do the post-processing. We don't need that. Okay, that's a bit of a funny, isn't it? Okay, let's try that again. Okay, so we'll go ahead. What do we have? Ah, perfect. No errors. Okay, awesome. So that is nice. but of course we can't see it. So the next thing I'm going to need to do is to go in and I'll call this apply post processing. So we don't need that early exit. Fun. And really the only thing we need to do this is we need a render commanding, or we need a command encoder to draw our command to. So take that, but otherwise we are fine. Okay, again, we don't need to do this. Okay, so I'll just talk briefly about like why I chose to have these abstracted as functions and not classes. So if I were doing something like Vulkan, I would have an array of these, I would have an array of image views to draw to, and I would pretty much have management over that, right? But the issue is right now, we don't, there's probably ways to do it, but we don't specifically have a deterministic way to say, hey, this is the index of the thing that we're going to draw to. It's just not super fun the way this is sort of black boxed out for us. So because of this, because this is sort of dynamic, sort of black boxed, we don't have a way to like pre-record these render passes. Sort of. It wasn't something I felt like looking into. So long story short, that's why I'm doing it this way. Okay, but this is a post-processing stage, so we do not need depth testing. And we're going to draw over the whole screen, so we don't need a clear color. And this is going to be drawing to the screen, so we actually need the canvas view. All right, so we're going to arm up the post-processing pipeline. We're going to set our going to arm our frame buffer to read from it. So we're going to arm the frame buffer's bind group and then draw. And literally that's it. We don't need to do anything else. Oh, we do need to end the render pass, of course. Okay, so there you can see we've spun it up. So let's give this a go and see if it works. Oh, of course it's not going to work because I need to actually call that function. So we'll then go apply post-processing, recording all those commands, and let's see how this goes. Nice. So we can see it again. Now there's a few issues, or just one issue actually. We're upside down. But that's easy enough to fix. What we can do is just, I don't know why this opens up too. I don't understand. But anyway, I'm not too stressed about it. So I can just go over to my post shader and just flip the Y coordinate. Why not? There we go. That's now around the right way, but just for fun, let's go ahead and actually apply some effects. So what I'll do is I'm going to make this purple. This is a special request, so I'm going to make this purple. So what I'll do is I'll fetch the color of the pixel that I'm interested in. Then I'll get the average. Why do I keep doing that? I'm used to the old style. And then I will go ahead and I'll say, okay, we're going to have going to take that intensity, put it in as the red, green, blue components, and then do that. Nice, okay. So there we are in black and white. Why does it do that? Mystery. And then what I want to do is I want to apply some purple shading. And that took longer than I would like to admit, but the basic idea is we've got our black and white intensity. We're then shading a purple color with that. And there we have it. It's nice and purple. It's pretty cool. Yeah. Can leave that there for now. So I hope you had fun. I hope you're starting to see how this feature can be really useful, getting, you know, a series of textures and sort of slotting them together. We're getting into the meta stuff now. But yeah, all the best. Hope everything goes well, and I will see you again soon. Bye. Hi, so I just want to take a second to thank my channel supporters. If you would like to support the channel, it's just $2.50 a month. That's all I ask, nothing crazy, but I really do appreciate it. If you're unwilling or unable to financially support the channel, that's totally fine. It's not expected. The best thing you can do in that case is comment on the videos and explain like what you're liking, what you're not liking, what you'd like to see. But yeah, thank you so much. So without further ado, big thank you to Antonin Carret, Dankil Foles, Declan, Andalon Studios, Isaiah Meyer, Mathieu Derick, and Moyne. Thank you so much, my dudes. I really do appreciate it. Keeps me running, you know, keeps me motivated. But that'll be it for now. So have a great one, and I'll see you again soon. Bye.